Welcome to AI Shift Hub and another new important video. Hello and welcome. Today, we're embarking on a journey to demystify one of the most transformative technologies of our time, artificial intelligence. What exactly is AI? At its heart, artificial intelligence is a branch of computer science dedicated to creating systems capable of performing tasks that typically require human intelligence. This includes things like learning, reasoning, problem-solving, perception, and language understanding. The ultimate ambitious mission of AI is to build machines that can think, learn, and adapt just like we do. It's about replicating and even extending the cognitive abilities that make us human, creating a new frontier of technological possibility. To truly understand AI, we must first recognize that it isn't a single monolithic entity. Instead, it exists on a spectrum. First, we have artificial narrow intelligence, or ANI. This is the AI we interact with every day. It's designed and trained for a specific task. Think of the voice assistant on your phone, the recommendation engine on a streaming service, or the AI that plays chess. It can be incredibly powerful within its limited context, but it can't operate outside its predefined parameters. It can master a game, but it doesn't know it's playing a game. Next on the spectrum is Artificial General Intelligence, or AGI. This is the type of AI often depicted in science fiction. AGI would possess the ability to understand, learn, and apply its intelligence to solve any problem, much like a human being. It could learn to paint a masterpiece, write a novel, and then devise a scientific theory, all with the same underlying cognitive architecture. As of today, AGI remains a theoretical concept, a long-term goal for researchers. But we are not there yet. Finally, we have the most speculative form, artificial superintelligence, or ASI. An ASI would be an intellect that is much smarter than the best human brains in practically every field, including scientific creativity, general wisdom, and social skills. It would not just replicate human intelligence, but would vastly surpass it. The emergence of ASI raises profound questions and possibilities, representing a potential leap in intelligence unparalleled in human history. For now, it remains firmly in the realm of future speculation. So, how does this technology actually work? The driving force behind most modern AI is a concept called machine learning. Instead of being explicitly programmed with rules for how to perform a task, a machine learning model is given a vast amount of data and learns the rules for itself. It identifies patterns, makes connections, and improves its performance over time through experience, much like a human student. This ability to learn from data is what makes AI so flexible and powerful. At the core of many advanced machine learning systems, particularly in an area called deep learning, are neural networks. These are computational models inspired by the structure and function of the human brain. A neural network is composed of interconnected nodes, or neurons, organized in layers. Each connection has a weight, which is adjusted during the learning process. When the network is presented with data, like an image, information flows through these layers. The initial layers might recognize simple features like edges and colors, while deeper layers combine these features to identify more complex objects like faces or cars. This layered, brain-inspired architecture allows neural networks to learn incredibly intricate patterns from raw data, enabling breakthroughs in everything from image recognition to natural language processing. But how do we teach these digital brains? The process hinges on two crucial components: data and training. Data is the lifeblood of AI. Without it, a machine learning model is like a brain with no experiences. It can't learn anything. The quality and quantity of the data are paramount. For an AI to learn to identify cats in photos, it needs to be shown thousands, even millions of pictures of cats in all their different breeds, poses, and environments. This data is what the AI uses to build its internal representation of what cat means. Once we have the data, the training process begins. This is essentially the study phase for the AI. During training, the model processes the data and makes predictions. For example, it might guess whether a new image contains a cat. Its prediction is then compared to the correct answer, known as the label. If the model is wrong, It adjusts its internal parameters, the weights in its neural network, to make a better prediction next time. This process is repeated millions of times in a cycle of prediction, feedback, and adjustment. Through this iterative process of trial and error, the AI gradually refines its understanding and becomes more accurate. It is this rigorous training on vast datasets that transforms a blank slate model into a specialized, high-performing AI system. As AI becomes more capable and integrated into our society, we must confront a new and critical set of challenges centered on ethics. The first is fairness. If an AI system is trained on biased data, it will produce biased results. For instance, if a hiring AI is trained on historical data where men were predominantly hired for certain roles, it may learn to unfairly favor male candidates, perpetuating past injustices. Ensuring that AI systems are fair and equitable is a major area of research and debate. Then there is the issue of safety. As we delegate more critical decisions to AI, from driving cars to diagnosing diseases, we must be certain that these systems will operate reliably and safely under all conditions. How can we guarantee that an autonomous vehicle will always make the safest choice in a complex, unexpected traffic scenario? Building robust, predictable, and trustworthy AI is essential for its safe deployment in high-stakes environments. Finally, we have the question of accountability. When an AI system makes a mistake, who is responsible? Is it the developer who wrote the code, the company that deployed the system, or the user who operated it? Establishing clear lines of responsibility and accountability is crucial for building public trust and ensuring that there are mechanisms for recourse when things go wrong. These ethical considerations are not afterthoughts. They are fundamental to the responsible development of artificial intelligence. The impact of AI is no longer a distant future prospect. It is already woven into the fabric of our daily lives. Take your smartphone, for instance. AI powers the facial recognition that unlocks your device, organizes your photos by identifying people and places, and provides the predictive text that helps you type faster. When you ask a digital assistant for the weather or to play a song, you are interacting directly with sophisticated natural language processing AI. This integration extends far beyond our personal devices. In healthcare, AI is helping doctors analyze medical images like X-rays and MRIs to detect diseases earlier and more accurately. In transportation, AI is the brain behind the advanced driver assistance systems in modern cars, controlling features like adaptive cruise control and automatic emergency braking. It's the first step on the road to fully autonomous vehicles. From the fraud detection systems that protect your bank account to the recommendation algorithms that suggest what to watch or buy next, AI is working behind the scenes, making countless aspects of our modern world more efficient, personalized, and intelligent. As we look to the future, the potential of artificial intelligence is truly staggering. We stand on the precipice of breakthroughs that could help us solve some of humanity's greatest challenges, from curing diseases and combating climate change to exploring the cosmos. AI could unlock new levels of scientific discovery, automate laborious tasks to free up human creativity, and create personalized education and healthcare for everyone. However, with this immense potential comes immense responsibility. The path forward requires a thoughtful, collaborative, and human-centered approach. We must continue to invest in research, not just to advance AI's capabilities, but also to understand its societal impact. We need to build robust ethical frameworks and regulations to guide its development and ensure that the benefits of AI are shared widely and equitably. The future of AI is not something that will simply happen to us. It is something we will build together. Our challenge is to steer this powerful technology toward a future that is not only smarter, but also fairer, safer, and more prosperous for all. Thank you for joining this exploration of artificial intelligence. If you found this video insightful, please consider liking, subscribing, and sharing it with others. We'll see you in the next one.